Now, we looked last video at nonlinear graphs, and I said we're going to talk a little bit more about the quadratic one and the way we can change its shape. This is what we're doing now, quadratic transformation. So here is your general basic quadratic. Every single one of your y values is generated by taking an appropriate x value and squaring it. So here is your quadratic. Notice it's got a couple of features. Firstly, it's supposed to be going through the origin. It's badly drawn, but it goes through the origin. That's called its vertex, also known as its turning point. And at the moment, the y-axis is a line of symmetry, so it's perfectly symmetrical either side of the y-axis. Now, I can do some things with that. I can make that graph more narrow. For example, if I made it y was equal to 2 lots of x squared. So all the original x squared values now get doubled, so for the same value on x, instead of going up a certain distance of y, you're now going up twice as far. It's made the graph more narrow. And of course, if I multiplied it by a half, I'd make it wider, make it more fat. This is called dilation. Dilation factor of 2, dilation factor of a half. Make it more narrow if it's bigger than 1, wider if it's in between 0 and 1. And of course, if I made it the value at the front, the a value, negative, it flips upside down. So the orientation of it, whether it's that way, that is when you have an a value that is positive, and if it's this way is when you have an a value that is negative. The shape of the graph. I call this one a smiley face quadratic, because a is positive, happy, have a smile. Smiley face quadratic. And here, negative, unhappy, I call that a frowny face quadratic. These things about a being positive or negative are going to come into play a little bit later when we start drawing graphs of quadratics. You're going to need to know the shape of them. So far, the shape is determined by the a value, whether it's smiley face or frowny face, a being positive or negative, and the a also controls the dilation, making it more narrow or making it wider. Now, you can move quadratics around as well from side to side, and you can also move them up and down. So if I just have my graph here again, so if I draw my y equals x squared, if I were to add 1 to it, everything moves up 1 place and passes through 1 on the y-axis. The two graphs are exactly the same shape. They would slide perfectly one on top of the other. One's just been shifted up by 1 unit. I can also move it to the side. I could shift it over like that by +1 moves that way. I could put that in there, for example, and that would have the effect of shifting it to the side. It actually interacts with the a value. We'll look more about that later, but having this x term here and its coefficient will have the effect of moving the graph left and right. So when it's in its general form of y is equal to ax squared plus bx plus c, the a value controls its dilation. The b value is going to have an effect upon its shift left and right, and the c value is going to affect its shift up and down. There's another way we could also write it. For example, I could write it like that. It's a perfect square. This is a very easy one to do. It's still going to be symmetrical, but this time, instead of it symmetrical about the y-axis, this number in here has shifted it 2 units, not in the negative direction, but 2 units in the positive direction. So there is now my line of symmetry. And once again, a little investigation in class, you can work out why a negative number in here shifts the graph to the right, and why a positive number in here would shift the graph to the left. Now, this particular format here, I'm going to stretch it out just a little bit more. This one. That y was equal to x minus 2 plus 1. This is sometimes known as the turning point formula. This one's a really easy one to graph. So I know the graph has been shifted 2 units to the right and it's been shifted 1 unit up. So I now know its turning point, its vertex, is going to occur at 2, 1. Written like that, you just look at it, you just read off x coordinate and y coordinate of the turning point. 2, 1, there's the turning point. It's got a positive a value, so it's a smiley face quadratic, and it looks like that. Now, just out of interest, and it's going to come into play in a lesson or two's time, I can put any number at the front here that I want. I can put 3 at the front if I wanted to. It's not going to affect the turning point. 2, 1's going to stay the same. Sorry, I forgot to put a squared in there. Having the 3 at the front, it's going to keep exactly the same turning point. It's just going to make it become more narrow. I can put a negative 3 at the front. It's going to keep the same turning point. It's just going to invert it. So another general form that you need to know about for quadratics, as well as that format, another one is y is equal to any number you want at the front of x minus h all squared plus k. These two, they're using exactly the same quadratic, but they're written in slightly different ways to gain slightly different benefit. With this particular one, you can look at it straight away and work out what the turning point is going to be. And the turning point is going to be hk. So quadratic transformations. See you in class and we'll do a bit of work on that.